All right, let's jump right into this explainer. I'll be stepping in as your senior architect today to unpack a seriously crucial constraint within Active Directory domain services. We're talking about the multi-master constraints and single-master operations of FSMO roles. You know, Active Directory is famous for its multi-master replication, meaning any writable domain controller can accept changes. But certain operations absolutely cannot tolerate a conflict. And that is exactly what we are mastering today. Here is our architectural blueprint for the session. We'll quickly cover architecture and scope constraints, dive into how FSMO roles actually work under the hood, walk through transferring and seizing roles, verify role health, talk placement strategies, and finally, prep you with some AZ800 exam scenarios. Let's get to it. Part 1. Architecture and scope constraints. We're looking at the forest versus the domain to understand exactly where multi-master replication just won't cut it. Looking at the distribution hierarchy laid out here, you can see exactly how the scope breaks down. Up at the top level, branching out across the entire forest, we have two roles: the Schema Master, handling all schema modifications, and the Domain Naming Master, which controls forest topology, like adding or moving domains. Then, branching down into the individual domains, we have three domain-level roles: the RID Master, the Infrastructure Master, and the PDC Emulator. By default, the very first domain controller you ever promote holds all five of these. But as you build out and add child domains, each child domain gets its own distinct set of those three domain-level roles. Let's zero in on the RID master for a second. Check out how security identifier is actually built in this breakdown. Every single security principal, we're talking users, computers, groups, gets assigned a SID. Notice how that SID is stitched together by combining a static domain side with a unique relative identifier, or RID. Now, to make absolutely sure two domain controllers don't accidentally create the exact same SID, they're each allocated a unique block of 500 RIDs, assigned directly by that RID master. And tracing the traffic patterns shown with all these incoming arrows for the PDC emulator, wow, you can really see why this role is the heavy lifter of your domain. It acts as the central hub. It's your authoritative domain time source, the immediate receiver for urgent password replication, the default target anytime you edit group policy objects, and the ultimate authority for processing account lockouts. Honestly, it's by far the busiest FSMO role in the whole bunch. All right, moving on to part 2, FSMO role operational mechanisms. Let's see how this stuff actually works seamlessly in the background. So, when you need to make forest-level modifications, the system is incredibly strict. You literally have to explicitly register the schema snap-in using this specific reg svr32 command to target the schema master directly. If you try to write a schema change to any other domain controller, nope, that operation will instantly fail. The architecture essentially forces you to talk to the single master. Take a look at this visual flow of a RID pool request. It is a brilliant piece of engineering for fault tolerance. As a domain controller uses up its allocated RID pool to create objects, it eventually hits a 50% threshold. At that exact moment, following the downward arrow, the DC preemptively, asynchronously requests a brand new block from the RID master. This means if the RID master goes offline, object creation doesn't immediately break. Your local DC just keeps chugging along using its remaining RIDs and only fails if it completely runs dry. And right here we have the urgent password replication flow mapped out. Follow the path. The exact second a password gets changed on a local DC, it totally skips the standard 15-minute or site-link replication schedules. Instead, it packages up that change and pushes it straight to the PDC emulator. Why do we do this? Well, to prevent that awkward scenario where a user changes their password, walks over to a different building with a different site DC, and suddenly can't authenticate. The PDC emulator always has the latest password state. Section 3, Implementation. Let's talk about transferring and seizing roles, which is a mandatory skill for any architect. Okay, the absolutely crucial takeaway here is understanding the stark difference between transferring and seizing. A transfer is a graceful, highly coordinated handshake between two healthy online servers. A seizure, on the other hand, is a forced, unilateral, hostile takeover during a catastrophic disaster where the original role holder is completely, permanently dead. Seriously, you never, ever seize a role if there's even a chance the original server might boot back up. If you prefer the graphical interface, you can see the specific tools mapped out for each transfer here. You'll notice every role has its own dedicated administrative snap-in. You've got the schema snap-in for the schema master, domains in trust for the domain naming master, and good old Active Directory users and computers for those three domain-level roles. But let's be real. As an architect, you're going to rely heavily on PowerShell. This single commandlet on the screen, move-AD directory server operations master role, is a lifesaver. It lets you efficiently move one or even all 5 roles in a single line of code. Just remember our golden rule. You only tack on that -force parameter when you are executing a unilateral seizure of a permanently offline DC.
Section 4. Verification of role health. Because moving the roles is only half the battle. After any role movement, you have to aggressively verify things. You absolutely need to run these core CMDlets. Get-AD forest and get-AD domain will confirm the target DC actually grabbed the roles. Rep-admin/rep summary proves AD replication is healthy across the board. W32TM ensures your time sync is properly pointing to the new PDC emulator. And DC-diag validates that your DCs can successfully chat with the RID master for new pools. Whatever you do, never skip the verification step.
Part 5. Architect notes on placement strategies. This is where design decisions literally make or break your environment. Walking through the decision tree logic shown here, we hit the golden rule of AD architecture. Follow the branches. If you're running a multi-domain forest and you stick the infrastructure master on a global catalog server, it's going to hold a read-only copy of all objects in the forest. Because of that, it will never see cross-domain references as stale, and it will completely fail to update them. Long story short, unless every single DC in your entire environment is a global catalog, you have to keep the infrastructure master and the global catalog strictly separated. Let's pivot to disaster recovery. If you're backed into a corner and have to seize roles, you must follow this exact protocol step by step. First, guarantee the old DC will never ever boot up again. Second, seize the roles, but prioritize the PDC emulator and RID master first, since they directly impact authentication and object creation. And step 4 is the most critical. You absolutely must use NTDSUTEL to run a metadata cleanup to purge the failed server's records. If you don't do this and someone restores that old server from a snapshot, you're going to trigger a split-brain scenario that can literally destroy your forest and completely wreck your weekend. Finally, Section 6, Exam Callouts. Let's tackle some AZ100 scenarios, because Microsoft really loves testing these specific edge cases. Imagine you're taking the exam and you get a scenario where suddenly no one can create a user or computer account across the domain. Boom, your immediate diagnostic answer needs to be the RID master. Specifically, you want to verify if the RID master is online and check if the local domain controllers have completely burned through their allocated RID pools. Here's another one. A domain controller is permanently offline, and roles have to be moved. Watch the wording carefully here. If the scenario explicitly says the role holder is unreachable or permanently offline, you simply cannot use GUI tools like Active Directory users in computers, because those only do graceful transfers. You must select PowerShell with the -force parameter or use NTDSUTIL to forcefully seize those roles. Okay, what about time synchronization? Which domain controller should sync with an external NTP source? This is testing your knowledge of the strict time sync hierarchy, and the correct answer is always the PDC emulator located in the forest root domain. All member servers sync with their local DCs. Child domain DCs sync with their PDC emulator. Those child PDC emulators sync with the forest root PDC emulator, and that single root PDC emulator is the one machine reaching out to an external NTP source. So, I'm going to leave you with this final thought. If your primary domain controller literally goes up in smoke tomorrow, are you confident enough in your metadata cleanup skills to save the entire forest? Are your roles deliberately placed and your disaster recovery CMDlets ready to go? Thanks for hanging out with me on this explainer, and I will catch you in the next one.